Good morning, one and all. Today, in the compiler design subject, previously we discussed several topics, and in continuation, we are going to give a brief overview of parsers such as SLR, CLR, LALR. SLR means simple LR parser. CLR means canonical LR parser. LALR means look ahead LR parser. So these three parsers. In the previous session we discussed about LR parser. Now SLR and CLR LALR parsers. What is the concept and how the structure, parse table, data flow diagrams can be implemented in this class. First, let us see SLR parsing is a LR parsing, same as previous which we have taken the concept LR. See here, now to construct this simple SLR parsing table, first we have to consider the grammar which is a context free grammar. Yes, we have, that is left hand side, and reduce move only one in the follow of left hand side. This is the fundamental step of simple LR1 parsing table. Now in this various steps are available. First step is context free grammar, and second step is verify ambiguity of the grammar. Verify, we know in the previous classes how to eliminate ambiguity if the grammar is unambiguous. So, how to eliminate. And we also know that add augmented productions for the given grammar. Previously, in the case of LR parsers, we have taken. And the canonical collection of LR0 items are also we have seen in the previous. And follow that data flow diagram and parsing table. So data flow diagram, which consists of several states, that is I0 initial state, another state I1, I2, I3, like that. We are going to describe the several states, and all these states can be written with the transitions from one to another with the help of arrow marks, then circle notations as stats, and that is to be considered as data flow table. Parsing table, we are going to write parsing table in such a way that set of all states across rows and columns, all the terminals across to be written, and these to be considered. So these steps are to be taken place in simple LR parser. Now we are going to briefly take with an example how it can be processed and then constructed with the tables and diagrams of this SLR parser. Consider the example: S derives E and E derives E plus T. One more, E derives T. Another rule, T derives T star F. One more rule, T derives F. F derives N. Now we all know that we have to keep a dot symbol at the initial first position of the every production. That means suppose if you consider S derives E, then you have to consider the dot position at the initial right hand side of the production. That's what we have written. Similarly, E plus T. Similarly, T star F, F derives N. For all the productions, we have to consider this dot. This is called as augmented production. That means why you have to insert the dot symbol. We know that when to stop the grabber. That's why you have to keep this dot symbol and keep on moving the dot symbol at each and every of the transition, and corresponding action go to until the dot comes to the last occurrence of the character. And if you determine that after dot there will be no other symbols are there, then we are going to stop the procedure at that particular point of the transaction, that is state, and then we are going to calculate the parse table and diagrammatic notation. So that's why the augmented productions are initially that is required to verify whether the grammar is reached to the endpoint or not. So that is the first, that is the, already we know that the grammar is ambiguous, it is context free grammar. Then we have canonical collection of LR of 0 augmented production. Now we are going to canonical collection. How canonical collection of 0 items can be formed. So here we know that the state I0 first initially, and what are the the first production, that is S dash. This is the augmented production initially. This is the augmented production, and we are going to insert the dot symbol at the end of each of the rules of the production. Now for this rule, we are going to keep a closure operation. So that closure operation is to be determined by this one, that is I0 equal to closure of the corresponding. This is the first production, augmented production, where in the given grammar this augmented production. And for this, what are the productions which are starting with E? Why? Because here after the dot symbol, what is the first, that is the, what is the symbol that is appear after dot? So that is the E. So that's why we have to list out all the productions in the given grammar which starts with E. So here this is starting with E, this is starting with E. Here there is no starting with E, but this and up. So we have to list out what? We have to list out the corresponding the rules which are starting with E. So we found out that is to be written E derives E plus T, E derives T dot T. So these two can be placed. Now so here the I0 state. Now add all productions which are starting with T and F in the modified state I0. So what is the E? We have written the two productions for this case. Next T followed by T, these two productions. Next followed by F, this production. So the I0 state is completed. Now I1 state comes to the I0 comma E. So we have to perform the closure operation with E. So I0 comma E. What is E here? E derives first S dash derives dot E. So if you perform the closure operation, then it becomes S dash derives E dot. Now similarly, if you perform the closure operation for dot E plus T, because this is I0 comma E. I0 comma E. These two are performing I0 comma E. Now in this one also, if you perform the dot symbol can be moved only one character occurrence of the each other. So here after E one symbol, then we have to keep the dot symbol. Previously where it is dot symbol is to be kept at the beginning, that is the given rule. We have moved this dot symbol at one position. Okay, similarly we applied I0 comma E. Now I0 comma T. This is the closure of I1. Now I2 can be obtained. I0 comma T. What is T here? What is T here? T derives dot T. Another one is T derives T star dot T star F. T dot T dot. Now here we have to apply that T dot. T derives T dot. Now T derives T dot star F. Now here there is a mistake, that is here we have to write T derives T dot star F. Now F I3. What are the rules that is to be available for F? So here T derives F, this one. So we have to make that I naught comma F. So what is the rule that is to be obtained? T derives F dot, because the character appearance of the insert symbol dot at the one more position ahead towards the right hand side. So that's why we got I naught comma F. Now the D I naught comma D, F derives ID dot. Last one, that is F I5. I5 contains go to I1 plus. So here what is the plus operation here? E derives E dot E. This is the plus operation. Now we have to perform the dot after the plus. Then we got T. So after completing the states such as I0, I1, I2, I3, I4, I5, then any other states still form the occurrence. Why? Because it is augmented grammar still not reached the end of the character of each of the right hand side of the productions. So that's why you have to consider one more time, that is I5. So previously I5 is I plus dot. Now it is moved to T. What are the corresponding occurrences of productions for the T? That is to be included. Then F we reach it. Then what are the corresponding F we have to consider. So like that we have to write each and every productions of go to statements. Then we reach it to the I3, I4, I5, I6. I6 also we have written, that is ID, and reach it to the end, then which can be same as I4 also, which is same as I4, then we have to write that one. Then I7 E plus T dot, it reached the end of this one. This is also end of the reach at the end of the dot symbol. Like that each and every state which is to be identified and reach the dot symbol at reached. Then we have to form a data flow diagram. So what is the states that is to be considered in I0? So these are the rules which are to be considered for the I0. Why? Because after reaching IE we are going to write two rules. Because of T we got two other rules. Because of F we got one more rule. So based on this, the data flow diagram can be written with these rules: S dash, E, capital E, T, T and F. So based on this, we are going to write I0 comma E. What is I0 comma E? So here, what are the productions which contains E? That is S dash, E dot. That is one, moving the dot symbol. One E derives capital E dot plus T. So this can be considered as I1. This step can be considered as I1. So this is the E. And the second one, the capital T. I0 with capital T. So I0 with capital T, what are the productions which are contains T? So here T derives dot T star F. And one more, T derives dot T derives T dot. It derives E plus T, E derives T, E derives T. That is, what are the productions which contains that one? That is E derives T dot, T derives T dot star F. Now capital F. Because of capital F, we got production, that is I0 capital F we got that is one production, that is T derives F dot, and ID identifier we got I naught comma ID. What we got? F derives ID. So like this, initially we got a new state, so we are going to describe each new state, give a new number, that is I1. Say I1 is the new state which is formed after getting the closure of E. Next, after getting the closure of T, we are going to get a state, new state I2, and we are going to get a closure I3, and we are going to get a closure that is I4. Once again, verify whether the closure appearance dot symbol is reached at the end of each of the rules in the given state. So, for example, if we consider I1 state, the rules are S derives E dot and E derives E dot plus T. So, this is the production which is appears at the, in case of transition in state, that is I1. Now, this I1, first verify I1 after E. That means, what are the operation that is to be considered? That is plus operation. Why? Because it is not reached the end of state. So that's why this plus operation to be considered, and this is to be written as a new state. It processes to the new state. E derives E dot plus T can be processed into closure of I1 plus. Closure of I1 plus. Then we are going to get a new state, that is a new state can be written as I4 is completed, so that's why a new state can be written as I5. In this state, verify the transition, that is E derives E plus dot T. So here we reached one more symbol, that T. So what are the productions which starts with T? That is also to be included in the states. So that's why T derives dot T star F and T derives dot F. These two rules are to be included, and also F which contains dot ID. So these are the rules which are to be included in the given state, that is new, forming the new state, that is called as I5. And from I2, verify any. From I2, if you look, that is the two section rules, that is T dot, that is reached end of this one, then no need to go to the further state. Whereas the second rule, T derives T dot star F. So this rule is not attached this one final transaction. So that's why this is to be processed with one of the closure operation. The closure operation here is star operation. So that's why the star is to be placed as the initiation of the start, and then we have to perform closure of I2 comma star. Closure of I2 comma star. What we are going to get a new state, that is new rules, that is in the given state, that T derives. So here dot is kept at the end of the one more symbol ahead. So that's why T star dot F. Now what are the rules which are required for F? That is also to be included in this initiation. So in this F is required. So F derives dot ID. F derives ID. So that is to be stopped. Why? Because here it is not a non-terminal. Whenever non-terminal, then that is to be included as the corresponding rules of this one. So that those two can be placed as a new state, that is considered as I6. That is considered as I6. Now we reached two more new states, that is I5 and I6. And if you observe I3, then it contains a rule T derives F dot. So no need of further passing of any closure operation on I3. And I4 also, if you observe this rule, F derives ID dot. So it is also reached the end of the operator, dot reached the end of the, that means after the symbol there are no further symbols currents are available. So we can stop both I3 and I4. And we have to consider what are the states which does not contain this dot operation at the end. Verify the case that is I5 is not reached and I6 is still not reached. So we'll move the further process with I5 and I6. So here I5, if you observe the case that is E derives E plus dot T, that is to be closure operation, we get E plus D dot. And similarly, T derives T star after moving this dot symbol, T dot star F. Now here, if you consider the non-terminal EF, we have to include this F transition also. So F, to be consider the F transitions as F derives ID, and we have to write what are the star, that is T dot T star dot F derives ID. So these two can be written, and these two are same as the closure operation I6. So we have written I7. For I7, after performing the included F state, so here F symbol, the corresponding transitions we have to include. What are the transition, that is F, that is T dot star F. So T derives T dot star F, and the corresponding F also to be included. So that's why you got what is the result, I6. Now here from I6, consider the operation, that is closure operation with F. So I6 comma F, closure of I6 comma F, we are getting a new state. What is the state here? T derives T star F dot. So here F is reached to the end of the symbol. So there are no further symbols. We can stop this process and we can name it in a new state I8. But that is to be considered. Whereas second, closure of I6 comma ID. So if you make F derives ID dot. So here this is also reached the end of the state of this one. So we can stop this one at this process, the I6 also. But what is the reach point F derives ID, which is same as I4. So that's why we have performed the link instead of writing a separate state. If any other states are already exist, then you have to give a link to this one. So that's why arrow mark is given from I6 to I4 with a symbol that is with transition, that is ID, closure operation with I6 with ID. So no need of writing separately I4 once again. Even if you write the same transition, that is the double occur. So that's why instead of avoid duplicates, we have to write give a arrow mark which is same as that one. Similarly here in I7 also, after performing this dot symbol, then we got T derives G star dot F. So that is once again contains the I6 only. So that's why the arrow mark is given as star operation. So by this we can end up with all states, that is I0, I1, I2. So this is a diagram which representing the data flow diagram for all the states. For the parts table, we can write as rows. What are the states here? I0, I1 up to I8 as the rows of the corresponding table, and the columns is to be included as what are the non-terminals which are available in the given grammar. What are the non-terminals which are available in the given grammar? So capital E, capital T, capital S, capital T, capital T, capital E, capital T, capital S. Capital in this given grammar, what are the non-terminals? Capital E is one, and capital T is another one, and capital F. Capital E is one and capital T, and then capital F. These are the non-terminals which are to be written, which are to be included as go to. We have to take the two parts. One is action part and second one is go to part. here in the action part, what are the terminals that are available in the given production list of this one. So we know that ID is 1, and the plus operation, star operation, and we have to include a dollar symbol because the grammar is reached accepted by the SLR parser or not. So that's why we have to include dollar symbol. And then go to is to be considered the corresponding non-terminals. So E, capital T, capital F. So we have to return the same as rows. And the corresponding states in the data flow diagram, how many states we obtained? I0 to I8. I0 to I8. So those to be listed out as rows of this one. And whereas columns, we are going to list out with the 2 sections as action and go to. Action is to be considered the corresponding terminals, and variables are to be considered as a go to port. Now here we have to fill the entries of the parsing table. How to fill up the entries of the parsing table? See here in this given, first consider the state I0, and what are the entries here? ID plus star dollar and non-terminal CTF. Now for this row, what are the states? What are the symbol? That is, for example, here in state data flow diagram, I0 with closure operation capital E. Then that is moving to one more state I1. So that's why capital E in place of capital E, we have to write go to which state it is going. Which state it is going? I1. So that's why we have to write capital 1, that is 1 in place of that is E. And the same I0 with capital T, it is moving to capital T, moving to another state I2. So that's why I have to write 2. And capital F, it is moving to one more state, that is I3. So that's why I have to write as a row part 3 in case of F. So these are the entries to be filled up as a go-to part. Whereas if we come to the action part, what are the terminals? That is, here ID is the only one terminal and it is reaching to the state I4. So that's why in place of ID you have to consider the 4. For like this, we have to write the remaining states. For example, if you take I1, here this is the state I1, and what is the operation? This plus operation. This plus operation moving to the state I5. So that's why I have to write here for writing these entries shift, because actions are always to be written with the S4 shift and shift. So here I5, so I have to write S5. S5, only one entry S5. And from I1 there are no other entries, and we can say that at the dollar say accepting state. And like this we have to write the further remaining states also, I1, I2, I3 also state the consider I3, and from I3 there are no further states, it is moving to any other states. So there are no initiations from this state. It is a final state reached. So for these states, what are the states which are to be final to be considered and write as a reducing states. Here reducing states are that is I3 is one reducing state, and I7 is also one reducing state, and I8, because these are the final states. I3, I4, I7, I8. So these are the reducing states which are to be written with the separate rules of the section. Now I3, I4, I5, if you consider, for example, if you consider I5, the state I5 with the capital T, it is written to us 7. That is to be 7. Because state reaching to I7, so we have to write in place of T 7 across the row and column. Row is I5, column is T. So where the cell intersection, we have to include that number, state number, that is 7. And from this I5, one more operation, capital F, are also moving to that part, that is 3. And from this, it is also moving a capital I5, that is moving the 7, 3. Okay, moving to one more, that is ID. What is ID? Moving to one state, that is 4. Here 4 means S4. S4, that is capital I5. Then I6 are also can be written. What are the states which are moving from I6? So capital F moving to 8. So that's why 8 and I6 with ID, small ID. Then it is reaching to I4. I4 means S4. So we have two entries in I6, that is S4 ID and capital F is 8. So these are the two entries which are to be written across the row I6. So and the last remaining states which are to be available, that is I3, I4 and I7, I8. I3, I4 are the reducing states. Why? Because here we have to list out the rules with some numbers. What are the states which are rules which are available in the given I0? For example, here S dash derives dot E derives dot E plus T derives dot T star F, T derives dot F derives dot ID. So, for example, this is the rule 0, rule 1, rule 2, rule 3, rule 4. So, these are the set of rules which are formed. Now, what is the I3? If you consider the state I3, T derives F, that belongs to which rule? I3 is T derives. So, this is the rule which belongs to that rule name is R3. So, if you list out the rules with the corresponding names, then R3 becomes. So, what is the production here? T derives F dot. So, in state A3, what is the production that belongs? Here that belongs is R3. So, this is to be written across the action part of the corresponding state, that is I3. So, what is I3? Where I3 occurs, then I3 we have to write across the row ID place R4 and plus R4 and we have to write the cases R4 across plus star and dollar. Why? Because these three symbols only to be written plus star dollar. We have to consider the follow of previously we have computed first and follow computation. So what is the symbol that is to be appear at the right hand side, that is to be considered as the follow. So that's why here we have computed each of the symbols and first and follow. So what is the symbol that is F? So here follow of F. What is the follow of F? Star plus dollar. These computations are already in the previous videos we have computed for the different grammars. So see the previous videos for how to compute first and follow. So we have to get these three symbols. Based on this, only these entries to be written. So that's why plus star dollar. Only these three entries to be written. Why? Because in the state I3 we got one production rule, that is T derives F dot. So in T derives F dot, the follow of F, what we are getting the rules are plus star dollar, plus star and dollar. So that's why I have written. And if you come to the I4 it is to be considered as follow of T and the follow of F. So here what is the follow of? Here follow of F, here follow of T. So here what is the follow of F? Follow of F and follow of T are both are same. So that's why we have to write the reduction rule. Here what is the reduction rule here? For I4, F derives ID. So here we have to write I4 R5. You know 1, 4, 5. So here and I5, I6, I7, I8. What is I7? I7 is follow of I7 is follow of T, that is ID plus dollar plus dollar fall off. Fall off F dollar is plus one reduction rule, that is I7. I7 is E derives C plus T. So that is rule comes, that is R1. So that's why plus dollar. And I8 is also to be considered as reduction rule where it contains fall off T, that plus fall off T is plus star dollar. So that's why this T derives T star F, that is as reduction rule it is R3. Why? Because here we have to include a one more augmented production S dash derives S. So in this case we will get rules as R0, R1, R2, R3, R4, R5. So that's why you will get the production rule as, that is T star F, that is R3 we will get. So I8 will get R3 for the plus dollar star, whereas I7 will get R1 and these two fall off T dot derives T. So only the entries are to be marked with the corresponding follow computations. So this is what about the parsing table with the given grammar, and how to construct the parse table SLR. This is called as SLR parser, where first we need to perform the closure operation, and the initial step is augmented grammar and verify the grammar is context free grammar and ambiguousness, and then corresponding first step. This is the first step. Verify the ambiguity, context free grammar and ambiguityness. Then go for augmented adding, that is S dash adding. Then we have to find out the insert the dot symbol and place the canonical collection of the R0 items finding, and then starts the closure of I0, I1, I2 until all the states to be completed. After the dot symbol reach the endpoint, then after completing all the closure operations, we can describe about these data flow diagrams, and then we have to mention the corresponding entries, rows and columns with the states as I0, I1, I2, many states we obtained, and then keeping the action part and go to part with the corresponding variables and terminals, and then we have to list out the SLR parser based on the entries. So any entries, if you see, observe in this table, more than 2 entries obtained, then it is not a LR parser. Here all the entries are single entries only, so we can say that the grammar is whether the given grammar is SLR or not, means yes, it is an SLR parser. And the closure operations we can find out for each separately. And CLR parser is to be calculated as one of the added step from the previous SLR parser. So here the example which is to be considered for CLR is nothing but canonical LR parser, left to right post derivation. Then here also we have to write the context free grammar, define the ambiguityness of the grammar, and then initial augment production we have to add, and then finding the canonical collection of 0 items, draw the flow diagram, and then parsing table. But here, while finding out the canonical collection of 0 items initial, so this step is common for the previous SLR parser, that is adding the augmented production. But here a canonical list of items we have to include a first of this one. So what is the first of S? Initially it is dollar, whereas first of A. So here in the given grammar, what is first of A comma B. So that's why this to be written as A or B. So that is to be included for each of the production. Why? Because here dot dollar, then dot A. What are the productions which are started with which contains A? So that is to be listed out. These two productions are A. And then that's why you have written. But while writing these two productions, we have to write a dot symbol canonical as well as comma separated canonical items, such as first operation, first computation. We need to compute the first of the corresponding symbol. Here corresponding one is entry is after dot A. So that's why here we have to compute what? first of A. So first of A in the given list of the grammar is A comma B. So that is to be written as A slash B as the computation. So the same can be applied for the another computation A derives dot B also. That is second rule also. We have to write how many productions are there. Why? Because all the list out carried out productions are A. So all A productions will be listed out with this kind of this one. So this is the canonical LR parsers, which is first initiation step, and then that is to be carried out with the remaining operation like I1, I2, I3 also, and then we have to give the data flow diagram similar to the same as SLR parser. Only the difference here is we have to calculate this first of this one, and the same to be written as the separate states I1, here also I1. But here if we observe the I0 with S, we'll get S comma dollar, that is the accepting state, and I0 with capital A. I0 with capital A, we'll get one more rule, that is what are the rules? That is S derives A dot A, and then capital A derives small a dot capital A derives B dot B dot A dot B dot A. So this is the states these are the rules which are available in the state I2. And then here what are the symbol that is to be appended the look ahead, that is canonical collection dollar as the symbol, because at the first initiation S dash dollar that is to be included. Now as a separate class we will give one more description as separate look aheads with this one SLR CLR parser. Now today we will complete with SLR parsers as the data flow diagram and parse table. On the next session, we will come up with separately CLR and SLR parsers and what are the differences. There are a little bit differentiation like carry and look ahead parts. Those things will be described in detail in the further coming sessions. So all the descriptions and this one can be available, find out from the textbook, that is Compiler's Principles, Techniques, Alfred, Sethi and Willman. And today we'll stop this session. We'll come up with the next session. Okay, thank you all of you.
Like, share and subscribe. Hit the bell icon for more updates.